Management roles in semiconductor equipment manufacturing. In the semiconductor equipment industry, management roles are essential to aligning innovation, operations, and business strategy. This module provides a foundational overview of leadership positions and organizational structure across three core themes: leadership, operations, and growth. Leadership involves executive and strategic roles that steer company vision, drive technological direction, and manage cross-functional teams. These positions often include titles like VP of Engineering, Director of Operations, or General Manager. Operations refers to the daily execution of production and manufacturing tasks. Managers here ensure quality control, cost efficiency, equipment uptime, and production schedules. Finally, growth focuses on career development paths for aspiring leaders, outlining how technical experts can transition into management through mentorship, cross-training, and leadership development programs. Understanding these roles helps employees at all levels see where they fit into the bigger picture and how they can grow within the organization.
Industry overview: Semiconductor equipment manufacturing. Semiconductor equipment manufacturing involves the production of highly sophisticated machines and tools that are essential for making semiconductor chips and other electronic components. These tools support various stages of chip fabrication, such as photolithography, etching, and deposition. For instance, lithography systems are used to pattern extremely small features on wafers, while etching equipment helps define the geometry of those patterns. Deposition tools add layers of materials, atom by atom or molecule by molecule. Each category plays a vital role in enabling smaller, faster, and more powerful microchips. This industry operates on a global scale, with a market size exceeding $100 billion, highlighting its massive economic footprint. It also functions 24/7 to support non-stop demand from chipmakers worldwide. The non-stop nature of operations reflects the time-sensitive, high-throughput requirements of modern electronics production and underscores the strategic importance of this sector. Key characteristics of semiconductor equipment manufacturing. Semiconductor equipment manufacturing is defined by several critical characteristics that set it apart from other industries. First, ultra-high precision is a foundational requirement. Machines must operate at the nanometer scale, where even microscopic deviations can compromise chip performance. This level of accuracy is essential for enabling next-generation semiconductor technologies. Second, the manufacturing process itself is highly complex, involving multiple tightly controlled steps and specialized engineering knowledge. Coordination between disciplines like mechanical, electrical, software, and chemical engineering is critical to success. Third, the industry is built on cutting-edge technology that evolves constantly. Advances in materials, processes, and integration demand continuous learning and innovation. Fourth, manufacturers operate within a global supply chain, managing partnerships, logistics, and sourcing across continents. Lastly, the industry adheres to zero-defect standards. There's virtually no margin for error. This unique combination of precision, complexity, innovation, and global scale requires highly specialized management structures and skilled leadership to ensure success at every level. Organizational structure, management hierarchy. In semiconductor equipment manufacturing, a clearly defined management hierarchy supports efficiency, accountability, and cross-functional coordination. At the top is executive leadership, which includes the CEO, COO, and CTO. These leaders set corporate strategy, align technical goals with business outcomes, and oversee high-level operations. Reporting directly to them are directors across key domains: operations, engineering, quality, and supply chain. Each of these directors manages specialized functions essential to company performance. Beneath them are functional managers, such as the production manager, equipment manager, process manager, QC manager, and materials manager. These roles handle day-to-day responsibilities like workflow optimization, machine maintenance, process control, quality assurance, and material sourcing. At the operational level, floor supervisors and team leads, including shift supervisors, QA supervisors, and logistics leads, direct teams on site. This tiered structure ensures clarity in decision-making, streamlined communication, and effective delegation, all of which are necessary in a high-precision, fast-paced manufacturing environment. Organizational structure, management hierarchy. Principles. The management hierarchy in semiconductor equipment manufacturing is built on a clear and scalable framework designed to support complex operations. There are 4 distinct levels of management: executive leadership, functional directors, middle managers, and frontline supervisors. This structure ensures a defined chain of command, where roles and responsibilities are well understood. Each level has clear accountability and performance expectations, which is essential in a precision-driven industry. A cross-functional approach is also embedded throughout the hierarchy. Teams from engineering, operations, quality, and supply chain collaborate seamlessly, using integrated strategies to solve problems and optimize workflows. This fosters communication, innovation, and faster decision-making. Another key strength is the scalability of the structure. Whether a company is a startup or a multinational, the same management principles can be adapted to fit its size and complexity. This allows organizations to remain agile while maintaining control and operational excellence. Executive leadership roles. In semiconductor equipment manufacturing, the CEO and COO play distinct but complementary roles at the executive level. The Chief Executive Officer, or CEO, focuses on strategic vision. Their primary responsibility is to set the overall company direction and long-term strategy. This includes leading relationships with stakeholders and investors, ensuring the organization has the resources and support it needs to succeed. A CEO also drives revenue growth by identifying opportunities for market expansion and innovation. They play a critical role in building the executive team and shaping a strong, values-driven company culture. Risk management and compliance oversight also fall under their scope, ensuring the company navigates legal and regulatory requirements successfully. In contrast, the Chief Operating Officer, or COO, drives operational excellence. The COO manages daily manufacturing operations and ensures production efficiency. They oversee supply chain and logistics, quality assurance, and process optimization. Their responsibilities also include managing costs and improving operational efficiency, as well as handling production scheduling and timely delivery. Together, the CEO and COO ensure strategic alignment and operational execution. Chief Technology Officer. The Chief Technology Officer, or CTO, leads innovation across the organization by guiding the R&D strategy and setting the long-term technology roadmap. This role is critical in semiconductor equipment manufacturing, where staying ahead in technology is key to competitiveness. The CTO oversees the design and development of cutting-edge equipment and ensures alignment with customer and industry demands. A major part of their responsibility is fostering innovation and developing next-generation technologies that give the company a strategic advantage. They also lead and mentor engineering teams, helping attract and retain top technical talent. Additionally, the CTO builds strong external collaborations by establishing technology partnerships with research institutions, suppliers, and customers. These partnerships accelerate innovation cycles and bring fresh perspectives to problem solving. Ultimately, the CTO ensures the company remains a leader in technological advancement. Chief Financial Officer. The Chief Financial Officer, or CFO, is responsible for shaping and executing the company's financial strategy. In the capital-intensive semiconductor industry, sound financial planning and budget management are essential for sustainable growth. The CFO ensures efficient capital allocation and makes key investment decisions that support both short-term performance and long-term innovation. Their role also includes maintaining accurate financial reporting and ensuring compliance with regulatory requirements. This oversight reduces financial risks and supports transparency. In addition, the CFO conducts detailed performance analysis and develops metrics to track the company's health and profitability. This data-driven insight guides executive decisions. The CFO also leads investor relations and fundraising efforts, helping secure capital from external sources to fund innovation and expansion. Together, these responsibilities ensure financial strength and strategic alignment across the business. Operations Manager. The operations manager plays a critical role in daily operations by coordinating production schedules and managing workflow across teams. They ensure optimal resource allocation and monitor capacity to avoid bottlenecks or downtime. A key responsibility is planning and tracking performance metrics and key performance indicators, which help assess progress toward operational goals. They also facilitate cross-department coordination, ensuring that teams from production, quality, engineering, and logistics are working in sync. Another essential focus is cost optimization. This involves identifying inefficiencies, minimizing waste, and driving continuous improvement efforts to reduce overhead. The operations manager ensures the factory floor operates smoothly while aligning output with strategic goals. Production Manager. The production manager is accountable for delivering manufacturing output on time and at high quality. They manage production lines, ensuring that equipment and labor are deployed effectively. A major responsibility is yield optimization, which involves identifying losses and implementing solutions to boost efficiency. Shift coordination and staffing are also central tasks, ensuring that the right personnel are in place for each shift and adjusting as needed for demand. Delivery timeline management is critical, as delays can disrupt customer schedules and supply chain operations. The production manager also ensures safety protocols are enforced to protect workers and maintain compliance with regulations. Engineering Manager. The engineering manager provides technical leadership in semiconductor manufacturing operations. Their key responsibility is driving process engineering and equipment optimization, working to improve performance and reliability. They also lead the technical team in solving equipment or process issues and drive innovation through improvement projects. The role requires a focus on aligning new technologies with production needs while maintaining high engineering standards. Another key area is ensuring compliance with standards and specifications, which is crucial in highly regulated environments. The engineering manager bridges R&D, production, and operations, helping the organization adapt to evolving technical requirements. Quality Manager. The quality manager oversees all quality assurance activities, ensuring that products and processes meet regulatory and customer expectations. They implement and maintain quality systems that define standards and procedures for manufacturing. Inspection and testing protocols are designed and monitored to detect and correct defects early. Compliance with industry certifications and regulations is also part of their responsibility. They lead defect analysis and drive preventive measures to reduce recurring issues. The quality manager also ensures the company meets customer-specific quality requirements and supports audits and continuous improvement efforts across the organization. Equipment Manager. The equipment manager focuses on asset management, ensuring all tools and machinery function at peak performance. They develop preventive maintenance programs to avoid unplanned downtime and maximize uptime. Responsibilities also include calibration and validation, which are vital for precision and reliability in semiconductor manufacturing. The equipment manager handles procurement and equipment upgrades, making sure the latest tools support process needs. They maintain technical documentation for all equipment and work closely with other departments to align maintenance strategies with operational goals. Their leadership ensures stable operations and long equipment life cycles. Process Manager. The process manager ensures manufacturing processes are consistent, efficient, and continuously improving. They lead efforts in developing and optimizing processes, leveraging statistical process control to monitor performance. Process documentation and standard operating procedures, SOPs, are maintained under their leadership to ensure uniform execution across shifts and teams. They identify and implement continuous improvement initiatives, often in collaboration with cross-functional teams. A core part of the role is validating and verifying processes to ensure they meet performance, safety, and quality standards. The process manager drives process excellence and promotes operational innovation. Middle management success factors. Success in middle management within semiconductor equipment manufacturing hinges on several core competencies. The first is cross-functional collaboration. Middle managers must work across departments, operations, engineering, quality, and logistics to align objectives, prevent silos, and support coordinated execution. They serve as connectors, translating strategic goals into actionable plans across teams. Second, effective middle managers rely on data-driven decision-making. Using performance metrics, production KPIs, and trend analysis enables them to make informed choices that drive productivity, improve quality, and reduce costs. Another key factor is team leadership. Middle managers lead by example, motivating their teams, resolving conflicts, developing talent, and ensuring accountability. Strong leadership cultivates a high-performance environment. Lastly, continuous improvement is essential. Middle managers must foster a culture of innovation, encourage feedback, and support process optimization initiatives. These success factors ensure that middle managers not only meet their daily responsibilities, but also contribute strategically to the company's long-term competitiveness.